discussed a lot of information already. Therefore, I would like to show you the practical side of our part screening methodology and introduce you to the scorecard. So the scorecard really combines all the essential criteria we just looked at and helps you to assess the suitability of an application for additive manufacturing. On the left side, you find the information for the technical criteria, such as size, for example, dimensions and volume, material, so the current material you use and the equivalent, as well as quality. And on the right side, you find the economic perspectives and geometric complexity, manufacturing complexity, cost, value add, and also field for additional information. And also in the download section, you will find the scorecards, so you can fill these in for your application. And from our experience from all the past workshops, for the first high-level assessment in the beginning, we strongly suggest to discuss these applications in a diverse group setting. So next to R&D and other engineering colleagues from the business side, controlling, supply chain experts, etc., often can provide very valuable insights and bring in a new perspective to find innovative AM applications. And as a next step, you can then either challenge the evaluation by internal experts or also external experts, so getting in touch with us. Let's now have a look at a specific example. So one of our projects was a joystick for heavy machinery. Dimensions were roughly 9 to 10 centimeters in diameter and 18 centimeters in height. And volume 125 centimeters cubical. The current material was ABS, and we proposed PA12 as an equivalent. Quality-wise, we were looking at a high possible UV exposure during its use. Tolerances were 2/10, and a smooth surface was required. And from a certification perspective, we were looking into biocompatibility as well as a potential issue. The part was originally injection molded from 2 halves, and the integration of several controls and buttons was done afterwards during the assembly. So now we have to ask ourselves from technical side, how do we evaluate this application? And we actually focus on very simple evaluation criteria from high, medium to low, asking ourselves the question, so does the part fit into a current AM system? Are suitable materials available? And can the part actually meet the quality requirements for its use case? And a low technical evaluation, for example, would be something that is not possible with today's technology. Medium, something which is possible, however, we would need to look into redeveloping the part. And high would be something we can directly build suitable materials there and no issues from tolerances or surface. And for this application, we evaluated the part as high. And we then look at the economic fit, complexity on the manufacturing side. And for the economic side, we then also evaluate the part, asking ourselves, so how complex is the part? What are conventional production costs? And what is the value added with the part? We have a high technical fit from the first assessment and a medium economic fit. And what we then do as a final step is to visualize the results of our screening. Herefore, we plot the evaluated part and all the other parts in the Ecotech matrix. We've identified an application in traditional manufacturing and now take this to the next stage. We'll redevelop it. We will look at other design benefits. So for example, if we can improve the texture to some extent, if we can make assembly slightly easier, for example, and also calculate the corresponding business case.
Thanks for watching this video. If you liked it, please give it a thumb up. And if you'd like to have further information about educational content or other webinars from EOS, just click the links in the description box below. We hope to see you soon in one of our next videos. Until then, go and subscribe our channel. Bye!